Welcome to the last video in this our R series. If you have been following this series till this point, I must congratulate you personally and tell you have done a wonderful job. So in this particular video, this is our 20th video, and the plan was when we hit video number 20, we're just going to take it as a project, cover some scenario, and try to see most of these things you have learned from part 1 till part 19 at work. We might not see all of it, but we'll see most of it probably. So look at the scenario. Uh, you've happened to be a public health worker, and you are analyzing malaria cases. So let me just put public health worker instead of public health care workers. So you're analyzing malaria cases across Nigeria, for example, and you want to go from state to state. So in this video, we're going to be having discussions and preparing our mind for real world problems. Data analytics problems always come from you asking questions, gathering data, wrangling data, which involve cleaning and processing data, analyzing your data then before you do your visuals. But if you have to build machine learning models, do regression, classification, and all of these things, then at a particular point in time, you take some turns to do that. So let's just go straight to this scenario. And we want to, after we gather this data across Nigeria, we want to understand the following two core things that we want to understand: how socioeconomic factors like your income, your average income, your healthcare spending, and all of these things, how does it influence the prevalence of malaria, probably for policy making or decision making? And number two, you want to check whether if you invest in healthcare, will it reduce malaria incidence? These are real life questions that um, health workers need to be able to answer to help the government make policies. So I'm taking the first 3 minutes to explain all of this and we can get started. I want to use a data set. I already have a data set in my R area. I will upload it in a little bit while to see. The data set contains a couple of data for malaria. I want to check following KPI. KPI stands for key performance indicators. These are the KPI we want to answer. The first one, prevalence rate. The second one, top three states with the highest malaria prevalence. We want to see the correlation between healthcare spending and malaria cases. We want to build a simple regression model to help predict malaria cases based on healthcare, income, and literacy. So that's another KPI you want to answer. These are some hints for us to work with. We need to check things. Whenever you get your data, familiarize with data, check for missing value, inconsistent capitalization. Just check for all of these things. You can write a function to do all of this, or you can just check it one after the other. So let's get started and get into it. I am already excited about this. So we'll go back and forth in this question so you can see and answer them. Yes. So our R simplified, we want to handle malaria matter. So who else is excited? Let's get straight to it. First things first, we need to actually access our data. Assuming you have done your research, you've gathered your data. So, step one, we want to load our data. So, step one, we want to load our data. How do we load our data? I want to store it into a data variable and I want to use read underscore CSV and I want to load my data. My data is in the same folder as my project. I have a project called um, R Hanson. So I'll be loading this particular data, malaria data set. So I need to fix that data. It's having .txt, .csv. I need it to have just .csv. So I've normalized that to be able to read that for me. So just to be clear, so that we can have things really quick, let me just have a variable called file path, and I'll store my file path as malaria data set dot, so I can load my file path into this. So we just I like writing my code like story. So as soon as I write my code, I can see a few story. Let me see. Do I have any data yet? Perfect. So you can see we have data coming up and yeah, telling us we got data from Lagos, Kano, Kaduna, Rivers, Borno, all of these things. I'm already seeing some problems here. I can see a Lagos in 21. I can see another Lagos in number one. So we need to just quickly check through and see what's going on. So how can we inspect data? Maybe in step two, let's just call inspection. Let's not forget step one is gathering, step two, inspection. How do we inspect data? First, I can use my summary to just quickly check what my data is like in summary, and I can see mean, media, mode, marks for all of the metric values in summary. Then we might want to check our string data here, and this is telling us that we have a couple of things. Healthcare spending is an integer, and all of these things. So I'm already trying to inspect my data with 21 observations, seven variables, and all of these things. So we are bringing it up gradually to check. So we can see some duplicates in the data set already. How can we handle this? So let's say we want to clean our data. So I'll try to move as fast as possible. Right now, if our timing is going so fast, we have to pause the video, write the code, come back and explain it so that we can move a bit faster. So, but we want to clean our data. This is the first time I think we should be using a particular library. There are libraries in R like the ggplot, dplyr, and all of these libraries that we can use in advanced R. So basically, I want to remove white space, clean, fix capitalization, and all of these things. So I'll be using this library called string R in R. Then I will be calling it on this. These are our data state. I want to use it as a title to trim a couple of things just for data cleaning. It's a library that exists in R. So it say could not find a function string to title. So what do we do about that? um Let me call this library. I hope I have it. If I don't have it, it will raise an error. So I think it did that for us. If not, we should have seen an error that the library is not available. So probably the library is available, or the package rather. You can always see all your packages here, and if you want to search for an existing package whether you have, you can type it here, stringr. So you can see I already have it in my R, so I am good to go with that. So these are all your packages. So you can do more things in these. If I do any for our data, it will let us know if we have any missing value or any data is unavailable and all of this. It says we have a couple of data that is unavailable. So definitely we have some not available data. Similarly, you may want to check for duplicate. So you can go ahead and do duplicated on data. If you see a true or false, it will always show you. So you can see it showed us all of these false, 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 but in a place you saw true. So you're going to look at that too. So I discover we have a missing value somewhere. So I think in the H or so. So I'm dropping this in. I really want all of this to be in just one video, so I don't want it to be too much of video that way. So I'm dropping in this in and saying I want to handle a missing value here, and from this our data, we want to check and populate missing value based on the mean, so that we know based on the mean if we have any missing value, we want to do this and populate based on the mean. And you might wish to remove duplicates, like I earlier explained. If you want to remove duplicates, um, you can say from this data, we want to be sure we don't have any duplicates. So if we have any duplicates, automatically we don't want to use it for our data analysis because then it will be um, you might run into issues of uh, multicollinearity or something is a different thing entirely on its own. So we don't want any duplicates in our data set, because remember, it's always fact and integrity that we are after. So remember, we are proceeding with this and following our guide as much as we can. We have checked for missing values. We have normalized these. We have actually dropped extra white space. This is talking about outliers. Let's see what we can do to that. I want to save most of our time for processing our data at the end of this um, video so we can see. So, in our malaria cases, we have a few outliers, and we want to say any case that is above this, we want to turn it to the median value of this. So, we are handling the outliers at this point. Yes, we are gradually coming in. So, now, next thing we want to look at is some people call it a calculated field or call it data processing, but in this case, I'll just call it a feature engineering because now I want to look at the prevalence level based on the existing data. So I'll just call this feature engineering, and we want to create a new column of data based on this, and we want to call it prevalence. So if I call data here again, automatically we'll have a new column for that. You can see we have a new column for prevalence that we just calculated based on the ratio of malaria cases and population. So that we have enough time to do the regression. Um, I'll just go straight into the first KPI. Is this first or second KPI question that says we have our KPI questions here? We have done this prevalence malaria cases per 100,000 population per state. And we want to see maybe top three states with the highest malaria prevalence before we go to the correlation, before we go to the regression. So let's quickly um, run into that as fast as we can. So looking at top states right now, um, top three states that we want to see based on prevalence. So it says top states not found. We want to find the top uh, three states right here. So we're returning the top five. So we need to see the top three states. Quickly clear this out. And this should not be five. This should be three because we want to see top three states. So you can see it's showing us based on prevalence every data on top three states. So according to this data, it's telling us that the state, the top three states are Zamfara, Sokoto, and Ekiti in this year, and this is the population, assumed state. Disclaimer: this is all assumed data. This is not a real data. So it's telling us that the prevalence level based on top three states. So the top three states with high malaria prevalence are Zamfara, Sokoto, and Ekiti. The next thing we want to check is co correlation. So just for fun purpose, I will leave that to you to figure out. So I will just move to the next one, which is regression. From our KPI question, if you take a look at it, the fourth one is our regression model. We want to predict how malaria cases based on healthcare spending does it affect it and literacy rate. So let's go into that and see. So building a linear regression in R is so easy. Unlike Python, that you need to install the scikit-learn, import the um, regression class before you start using all of these things. In R, we can just go straight forward and say we want to choose a model. LM means linear model. We have logistics model as well and all of this. And automatically it's telling us that, okay, we want to predict these based on these other factors. We want to predict, you can see this is our target. These are our features. Or again, this is our dependent variable malaria cases. Healthcare, average income, and literacy are independent variable, all coming from data. So this will build our linear model for us. And if we want to see the summary of the model, we can now see a few things that we'll quickly have to talk about together so that you understand this again. Understanding of statistics come into play in this place, so that you'll be able to interpret your scores, your model output. So it's showing us the minimum, the first quarter, the median, the 75th percentile, and the maximum of our data that we have. And we have coefficients that we can take a look at: the healthcare, average income, literacy, how much they interpret. If if you are used to statistics, or you have used statistics to some level, then you should know what the t value is, the p value is, the r square value is, to be able to determine which of the feature or which of the variable has a higher impact. But I think almost all of them do: healthcare, average income, and literacy. So look at our significant coefficient to see all of these things. And I can 0.001, 0.005. This is less than that. So first thing we want to see is this r squared values 0.674. It means that all these factors, do we call them factors or target? All those features come together to account for 67.4% of the variation in malaria cases. The p-value too, very, very low, which is a good thing for us. So for the sake of this, the R squared adjusted as well. For the sake of this tutorial, you should know that those are the key things we check for: the R squared, the p-value, the adjusted p-value, and the F statistic. It tells us about the model fit, how far all the predictions are, and how statistically valid our model is. So our model is looking very healthy to me. So this model is healthy. We can use it for prediction purpose. But this video, I want it to end in the next 2 minutes. So maybe if you need me to do videos on models, but then, like I said, statistics is a must for us. So let's quickly do a plot to see visualizations. Yeah, trying to beat time here right now. Um, it says margin too large as expected. Let me see if I just reduce this off. Will it give me that? If not, we'll just have to save our plot. So I quickly pause this to write my code. I want to save my whole plot as a PNG. So let's just look at the file. Let's locate the file final plot.png. So let's quickly have a look at our plots. We are running against time just right now and see what it gives us. Okay, so this makes a bit of sense to me. It's showing me that the higher we spend on healthcare, the lesser we see cases of prevalence of malaria. You can see where we are spending more. These are all exponential values in millions: 2 e raised power 0.8, 3, 4, 5. So somehow for every 1 million we spend, the lesser we have as cases of malaria. So this is a negative correlation, makes a whole lot of sense. So that means if we invest more money in this, we are going to have less cases of malaria. So this will bring us to the end of this video. I tried as much as possible to see how I can package all of this as one. But if you need further video into advanced R, always you can always reach out to me. So this brings us to the final and the closing of this series. I'm glad that I'm able to provide this. Please follow us on YouTube, comment, share with your friends, and see you in more series. Just let me know if you want me to work on any series. Bye for now.